Okay, now we're going to look at solving rational inequations. So, for example, if we did something like 1 over x is greater than, let's put greater than or equal to 0, when is that true? Well, that's going to be true when x is greater than 0. Okay, so you're going to have a solution set to this, not just a single solution like the equations. So in this case, when x is greater than 0, this is true. But it'll never be equal to 0, so we can't include x equal to 0. So that implies that x is contained in the set from 0 to infinity. Okay? But it doesn't include 0 because this is undefined for that. What if you had something like x plus 1 over x minus 4, say greater than 0? Well, in this case, you have to look at some possibilities here. And, well, the top is 0 at -1, the bottom is 0 at 4, and it can't be defined at 4, but the bottom would be 0 then. So these are numbers where the top would change signs. It would go from negative to positive at x equal to -1, and this would go from negative to positive when x equals 4. So there's a method for doing this that is nice. It's called using a factor table. Okay, so this is called a factor table, like we did with the polynomial inequations. And we write the factors of this. The rules for multiplying and dividing integers are the same. So we can use that, this division, just like we would multiplication. So if we multiply these two factors, we get the same signs as if we divided. So we're going to make the breakpoints here -1 and 4, just like we did before. So this is going to change signs there, this is going to change signs there. Negative, 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 positive, positive, positive. Okay? And if we multiplied those two, it's kind of like dividing them. Then we get positive, negative, positive. And we're wanting to know when this thing is positive. So it's here and here. And therefore, x is contained in the set from -infinity to -1, or 4 to infinity. Okay? Not including 4, -1, because of the greater than 0. Okay? So we're going to do the same one now, just a little bit different. We're going to do x plus 1 over x minus 4 is greater than or equal to 0. Okay, do the factors again. So x minus 4, x plus 1. Doesn't matter what order you do them in on that part. Okay, those in. So -1 and 4 are breakpoints. Now, before we do this, we want to circle the parts that will make this equal to 0. So in polynomials, in equations, we circled all these. But in the rational ones, we're not going to. Because x can't equal 4, we can't circle 4. We can only circle the -1 and include that in our final set. Okay, so this one changes signs there, that one. And the product of those, so it's negative, positive, positive, positive. These negatives multiply to a positive, not at times, and a negative and a positive. So we want when it's greater than or equal to 0, so we're going to circle this, and we've got that circled. So now we have to write our set as x is contained in -infinity to -1, but this time I put a square bracket because I need to include -1, or 4 to infinity, and the round bracket there because we can't include 4 because it was from the bottom. Okay? What happens if we do something a little bit more complicated? So these are all going to be factored. You may have to factor them in your questions you're doing, or rearrange them and then factor them. This is the idea. So you got this over x plus 5 times x minus 1, and say that's greater than or equal to 0. Okay, well, let's do the factor table for this. It's going to look a little bit longer. X plus 2, x minus 3, x plus 5, x minus 1. Okay, got all those in there. And looking at the division and product of these is just like looking at if they're all multiplied when we're looking at the signs. Okay. So the lowest one is going to be negative 5, then negative 2, then 0, then 1, and 3. Those are the break points in order from least to greatest. Okay, x is going to change signs at 0, x plus 2 is going to change that as negative 2, negative 3, 5, and negative 1. So to the left of all those little blips, put in negatives because it's are all positive slopes here. And to the right, we put in positives. You could sum numbers in each interval to check it if you're not sure, but that's going to take a long time. So now here's the product of 5 negatives, so that's going to be negative. 4 negatives, it's going to be positive. And then we've got a negative here, positive, negative, positive. We want when it's greater than or equal to 0, so we have to look at the top numbers. So 0 I'm going to circle, negative 2 I'm going to circle, and I'm going to circle positive 3. I can't include negative 5 or 1 because they make the bottom 0 and you can't divide by 0. And I'm going to circle the positives here because it's greater than 0. So now I can state my solution sets as, well, x is contained in negative 5 to negative 2, including negative 2 but not including negative 5, and then 0 to 1, and then 3 to infinity. Okay, and that will be the solution set for that one. Now, what if we had something like this one here? Let's do x minus 2 squared x plus 4 over x minus 3 times x plus 1 times x minus 5, and say less than or equal to 0. Okay, let's try this one. Well, I'm going to put x minus 2 in here, but I'm going to square it. Okay? And don't forget to look for common factors if you have to cancel something out. X plus 4, x minus 3, x plus 1, x minus 5. Okay? So the lowest breakpoint here is going to be negative 4, then negative 1, and then it's going to go to 2, and then 3, and then 5. Okay, so this could possibly change signs at 2, but it's not going to because it's squared. Whenever you square something, it's always going to be positive. So put positive right across there. And then the 4's there, 3 there, negative 1 there, and 5 there. Okay, and then the product of all those, well, here you got 4 negatives, so it's positive, negative, positive, positive, negative, positive. So we're looking at for when it's less than 0 or equal to. So we have to look at the top numbers. include 2, and we include -4, but we can't include the others because they're from the bottom. Less than 0, we're going to circle the negatives. Okay? So now we're going to write the sets here between -4 and -1. So x is contained in -4 inclusive to -1 not including -1. And then we have to include x equals 2. Okay, it's up there. And then we have to include 3 to 5. We don't include the endpoints. Okay? And that'd be the solution to that one. So that's it for rational inequations.